Hello. Hello. Hello, good afternoon.
Good afternoon, sir.
Yeah, sorry for the inconvenience. I am Sri Kumar.
Hello, sir.
Yes. So, shall we start?
Yes.
Yeah, I'm Sri Kumar.
Yes.
I was working with a Toyota for more than 25 years. In that, around 9 years, I was with the Japanese Institute for the Southeast purpose in Saudi Arabia. Okay, then is it okay, my sound? Hello?
Okay, sir.
Yeah, okay,
Yes.
thank you.
Okay, sir.
So today's subject is hydrogen fuel cell. Before proceeding to the hydrogen fuel cell, now everybody knows about the e-mobility. Globally, the entire country is proceeding to e-mobility side. Okay, so let me show the reason why we are moving to the e-mobility. The main reason everybody know the CO2 emission. You can see from this screen.
Yes, sir.
Yeah, the entire mobility is emitting CO2, including ships, vehicles. You can see from that city view, the emission of CO2 is normally growing, and the global warming is the result. So because of that, the 42% emission from the automobile sector, we have to reduce. So for that, the e-mobility sector is growing like anything. India also moving in that direction. So by depending only the e-mobility, mean only electric vehicle, battery electric vehicle alone cannot solve these issues, because the countries who are already moved around 40% electrification done in Europe, in some of the European countries already reached to 40-45 level. But they are now facing difficulties with the power availability. So we need alternative solutions. So fuel cell will be one of the solution, like other mobility options. Okay, so that's why e-mobility fuel cell are in the picture. You can see the transition from the fuel cell vehicle to the ultimate eco vehicle, which is the ultimate eco vehicle, electric car and fuel cell vehicles, because they are not emitting a single carbon dioxide atom, carbon dioxide. Okay, so we're starting with the IC engine type vehicle, then we move to hybrid vehicle, then plug-in hybrid, and finally eco-friendly electric and fuel cell vehicles. So this is the transition happening in the automotive industry. So you are aware about the hybrid vehicles, which there we are using fuel plus electric batteries are there. So both, it's a combination of electric powertrain and IC engine powertrain. The same with the facility of charging, we call plug-in hybrid electric vehicle. Then finally, but still these vehicles still have a carbon emission, but comparatively they are emitting only less carbon dioxide. When we go to the ultimate eco-friendly vehicle, that is battery electric powered vehicle and fuel cell vehicle, in that fuel cell will have another added advantage, because these vehicles are actually 100% electric vehicle, but they are not using a charging facility. Only we have to do, we need to fill hydrogen. So this will be the subject today. So we are going to see the details of the fuel cell system. In this 1 hour session, we are going to cover about fuel cell system, then fuel cell transaxle, hydrogen system diagram,
So good afternoon, sir. Sorry for disturbing, but your audio is not audible, sir. Your voice is not audible, sir.
Is it okay now?
Yes, sir.
Yes, sir. Yes, sir.
So, so what about the previous?
Can you please repeat from that particular the previous slide, sir? Yes, from the hydrogen system diagram.
Is it okay?
Yes.
Yeah, here we are showing the transition of the automotive industry. We have started with IC engine and then hybrid vehicle, then plug-in hybrid electric vehicle. Then finally, we are moving to the estimated eco-friendly vehicle. Those are EV, battery electric vehicle and fuel cell vehicles. So, in this section, we are going to discuss about fuel cell system and fuel cell transaxle and also the hydrogen system diagram, high voltage system for the safety inspection purpose, and also the service plug grip for safety and voltage inspection for the high voltage safety. Finally, the refueling procedure and also the FC power can be shared to some other purpose like a power generator. We can use this vehicle. So this will be the content of our presentation today. So let us start with the system diagram with the components of the fuel cell vehicle. Here we are using Toyota Mirai as a example vehicle. In India, a lot of heavy vehicle industry started with the fuel cell development, like Tata already, their prototype vehicle is available in India. But globally, everybody knows that fuel cell Toyota Mirai is sedan type vehicle is already running. Thousands of vehicles are there all over world. In India also 2 vehicles available, one with our union minister and one with another university. So these today our subject, we will use this vehicle as a standard fuel cell vehicle. So let us see the components of Toyota Mirai, starting with the NIMH battery. You can see on the top of the the battery is located on the So this will be the NIMH battery on the top, because fuel cell vehicle is a hybrid vehicle. Because fuel cell system cannot store the electricity. So they are only generating electricity. We cannot store the electricity back into the fuel cell. So that's why we are using one battery, a high voltage battery. For safety purpose, we are not using the lithium ion batteries here, only NIMH battery. Maybe in the future, we will have lithium ion batteries also with the fuel cell type vehicle. So the first one is NIMH battery for storing the electricity during the time of regeneration, or even for energy management purpose, because the fuel cell will generate electricity, which is maybe not necessary at that moment. So some of the energy can be stored and it will compensate later on whenever the fuel cell output is less. And these yellow 2 tanks are showing in the 2 circles, yellow shape, that is the fuel cell tanks where we have storing, we are storing the hydrogen. Okay, my sound?
Yes, sir. But in your screen, the notification of Google Meet is showing that I can't understand what right in front of the notification.
Can you please hide that particular session, sir, that particular link? Can you please click on the hide button?
Oh, sorry.
Yeah.
Okay.
Thank you, sir. Thank you.
Is it okay now? No, sorry for the inconvenience.
Yes.
Okay.
Yes.
Anyway, the battery.
Yes. Okay.
The battery in orange color, that is the battery for storing the electricity during the regeneration time. And these two yellow circles are the hydrogen tanks. And the blue one, fuel cell stack, which is developing energy with the help of hydrogen and oxygen supply. And we have a brown box in front of that, that is the boost converter. The boost converter convert the electricity into higher voltage from fuel stack. So fuel stack is developing around the 370 voltage that will boost up to 650 volt to generate motive power with the help of motor. And also the same voltage we are using to compress the air for the fuel cell. And the next one is AC compressor. Normally AC compressor we are using for interior cabin air conditioning purpose only. But in this case, this AC system can use for the cooling purpose with the battery pack or even fuel stack and our transmission. Heating purpose, both will provide by the AC compressor. And next is the air compressor, which is integrated with the inverter with the converter and transaxle assembly. Then in front side, we have a cooling radiator. FC cooling radiator, which we are using for cooling the transmission, FC fuel cell stack, and also this can be used to cool the battery if it is necessary. So finally, the inverter with the converter assembly and transaxle with the MG. MG means motor generator. So the inverter with the converter assembly receiving power supply from the FC boost converter and then convert into AC signal, AC power supply and provide to MG motor. And also that power will provide to the FC air compressor. So these are the components and their functions. Now you can see in this picture an actual Mirai vehicle with all those components we have explained, like NIMH battery on the top of the rear tank. So the rear tank having higher capacity, around 62 liters of hydrogen we can store. And in front of that, there is one more tank provided that will be always under the rear passenger seat, hydrogen tank. Second, can store up to 60 liters of hydrogen. Then we have the aluminum color, which is fuel cell stack. The actual component are showing here. And in front of the fuel stack, we have the FC boost converter. This is the assembly having inverter with the converter. So you can see the inverter with the converter. And inside the transaxle, we have MG, that is motor generator. Why motor generator? Because this motor, whenever it is in motor mode, it is driving the vehicle, and during the time of braking, it will convert into generator and generate electricity. That electricity, we can store it in the rear battery. Then we have a FC air compressor attached with the same assembly and also AC compressor. So let us see how these systems are functioning. We have an air compressor attached with the inverter with the converter assembly. That air compressor continuously compressing the fresh air through the filter, then sent through a intercooler. So the compressed air, normally everybody knows that while compressing, it will increase the temperature. So that temperature can be reduced with the help of an intercooler is provided. So that cooled compressed air supplying to the FC stack. So FC stack, what is both side, they have one more supply from the hydrogen side. So left side, that means the negative side of the FC stack, we are supplying hydrogen, and the positive side of the FC stack, we are supplying compressed air. So what will happen? FC stack will generate electricity. It is generating DC, around 370 voltage will provide by the FC stack. DC power supply will generate. that 370 DC power supply going to the FC boost converter. That boost converter convert that into necessary voltage level according to the driving torque. Because this conversion is controlled by the fuel cell control ECU to our fuel cell vehicle control ECU. Okay, then according to the power supply coming from the FC boost converter, convert that into AC signal and then driving the motor. But here we have a judge point because the motor torque is judged by the FC control ECU. So fuel cell vehicle control ECU always giving the target torque to drive the motor. That torque requirement sometimes may be less than the power generated by the FC stack. So that time what we can do, the generated electricity can be stored in the battery. So by that way, we will manage the energy developed by the fuel cell stack. That's why we are showing one battery just below that inverter with the converter assembly. You can see the actual position is on the backside of the vehicle. So this inverter with the converter assembly is a decision maker whether need to store some of the electricity, like 10% of electricity back to battery. And some case, FC stack is not generating the necessary voltage because there may be a millisecond delay while converting the hydrogen and air into electricity. That time, the same battery will compensate. So immediately they can supply the voltage and next moment it will compensate by the FC stack. So that's why we are using the battery. Also, battery can store the electricity while we are doing the braking. So during the regeneration time, the same battery will store the electricity. So now it is clear the function of the FC stack system. Okay. So now I'm showing the fuel cell stack assembly. Am I audible?
Yes, sir.
Yes, sir. Yes,
Okay,
sir.
okay, thank you. Now, see the fuel cell stack in the middle of the vehicle, which is located in the earlier model. Now we have changed 2018 onwards. The design of this vehicle is totally changed. The location of fuel stack is inside the engine compartment. When they produced the first model Mirai means that is a Japanese word. In English, it is future. So that time, to bring the center of gravity further low, they provide the fuel cell stack under the location of the fuel cell stack was under the driver seat. So this fuel cell stack, you can see on that animation, there is around 370 cells are connected in series. Each cell developing around 1 voltage, maximum 1 voltage. When you supply maximum hydrogen and oxygen, it will produce 1 voltage. Okay. So we can say less than 1 voltage and less than 1 voltage. That will be the capacity of the fuel cell. When you connect them in series, you will get 370 voltage maximum. Now let us see this fuel cell, how it is functioning. So here I am showing one sample cell, and that cutaway, you can see the middle part, there is a membrane located, a violet color membrane, which is a polymer electrolyte membrane, sandwiched with the 2 catalysts for positive side and negative side. And then again, other sides, we have gas diffusion layers. So these are the major components. What is exactly happening? Through the negative side, we are sending the hydrogen, and from the positive side, we are sending the oxygen. So Hydrogen, what is happening while they are moving, we can see the components through this. It will be more easy. You can see hydrogen, when they pass through the catalytic layer, they are losing electron. So any molecule or any atom, when they are losing electron, what will happen? This hydrogen molecule will become ions. So the proton alone will move through the catalyst, through the membrane to the negative side. What is happening to the electron? The electron, which is passing through the electrode attached with the, so immediately after the gas diffusion layer, there will be electrodes, negative electrode and positive electrodes. So the electron which is releasing from the hydrogen will move through the electrode and come back through the positive electrode to the positive side catalytic layer. So when they meet oxygen atom there, they will join together and generate water. So this is the process exactly happening in the fuel cell. So these three components, especially that gas diffusion layer and also the catalytic layer and the polymer electrolyte membrane, all this together we have a name called MEGA. So this will be a very thin layer in the fuel cell. So let us see the detailed view. Here you can see the middle portion is the polymer membrane. And then we have a sandwich at both sides with the negative catalytic layer and the positive catalytic layer with the gas diffusion layer. At the end, we have a metal electrode which is helping the hydrogen to flow through vertically and also oxygen to flow horizontally. So there will be two separate electrodes. They formed in the form of grid to guide the hydrogen flow and oxygen flow. Okay, you can see the yellow particles. These yellow particles are the electrons. So when they lose the electron, the ions are charged. Hydrogen protons are charged. So they will move through the electrolyte membrane, and the charged electron can pass through the metal with the help of this metal particle, and they will join back in the positive side. At that time, the oxygen will combine together and generate water. So what will be the output of the fuel cell? We have a generated electricity plus water. There is no mechanical movement inside. There is no tear and wear. So no maintenance at all. If you can keep the system clean for long time, it will work. Functioning will be long time. So necessary cleaning, filtering and also sealing, proper sealing, everything required. So let us see that fuel cell stack, how the structural parts are helping to assemble the 370 cell together. So you can see both sides we have the electrode. This is the negative terminal which is connecting with the FC boost converter. This is the positive terminal. So in between, the cells are serially connecting. Okay, and we have a safety concern here. Do not, if there is any chance to touch this component, if there is hydrogen and oxygen inside the stack, what will happen? It can produce electricity. If the voltage generated is more than 60, that will affect our heart ventricular valve. So it will be dangerous. So we have to be very careful. Just for studying purpose only we are explaining, but when we are coming to the actual practical, or is there any chance to measure or conduct any research or any testing or validation time, if there is any chance to touch, we have to use proper safe personal protection equipments like gloves and all. Okay, so these are the structural parts to assemble all the 370 cells together. Now, when we coming to the individual cell in actual fuel cell, how they composed of? do you know the thickness of one cell is around to 1.3 millimeter only, mm only. That means we have 370 multiplied by 1.3. You know that what will be the size of the. So it is very thin layer. In that the electrolyte membrane and gas diffusion with the catalytic layer and gas diffusion layer assembly together one unit. That is the yellow part. That is the main device to generate the energy. Then we have a supporting like a 3D fine mesh flow field, which will help the oxygen to flow vertically. And the other side, we have a, you can see the holes provided on the side of the cell. Here we have a inlet of the hydrogen, and the other side, see, this will be the outlet from where the hydrogen is coming out. Okay, so hydrogen will circulate until the density of the percentage of hydrogen reduced. So the pressure will automatically reduce. There will be pressure sensor, and the hydrogen supply system will act on top of the hydrogen. And same thing in here we have the bottom holes are provided for, that is the ventilation to allow the, so there will be one manifold to supply the air from the air compressor. The cooled air through the intercooler will supply through this hole. So the air can be guided with the help of the 3D fine mesh. So when the air flowing vertically, it will comes out through the upper holes. Okay. So this air, when there is percentage of oxygen still available, it will circulate, and that the circulation depends upon the solenoid valve provided on the exhaust system. When the air oxygen percentage is reduced, then they will be escaping through the exhaust gas is provided, air exhaust outlet is provided, and exhaust pipe also available. But these exhaust is not like our normal IC engine vehicle exhaust. This exhaust is just only the remaining components of the air elements like nitrogen and other gases. Okay, so that will escape through but the temperature will be little bit high, 80 degrees centigrade temperature will be there. So that is not same like our exhaust gas from the IC engine. So no need to use any metal pipe, just plastic pipe enough to guide this exhaust gas to escape outside. Clear? And we have a proper gasket and also the rubber sealing to avoid the mixing of hydrogen with the oxygen. So there is no chance of mixing hydrogen, because this you can see the cell alone, it's very thin, 1.3 mm only, and they are tightly packing to produce 370 volt. At that time, there is no chance of leaking hydrogen to the oxygen side or oxygen to the hydrogen side. Okay, so that's why additional gasket and protective separators are provided. Now, this is a phenomena happening inside the fuel cell during winter time, not in our country, maybe in here in Kashmir area or wherever we have low temperature. In that area, there is a chance of ice formation in the fuel cell. So if ice abnormally accumulating or water accumulating inside the system due to low temperature, ice will create. And next time when you turn on the vehicle, the oxygen cannot or air cannot pass through the tiny holes provided in the 3D mesh. So what will happen? Vehicle cannot, so system cannot generate electricity. So we have continuous, that we will see in the exhaust side, we have a continuous water releasing mechanism available with the help of pressurized gas, air. Air is available in our air compressor. So air compressor will work even though you turn off the vehicle. The air compressor will work for a few seconds, and that will allow the water to comes out completely from the fuel cell stack. So we have a problem that we have a solution also, and the coolant temperature can maintain to higher level with the help of our new air conditioning system can generate a high temperature coolant that will send through the. So in the previous slide, sorry, I forget to show you the previous slide. We have a FCC inlet. What is FCC inlet? FCC means the coolant. So the coolant continuously supplying through the entire fuel cell to reduce the temperature while they are converting the hydrogen and oxygen into water. Electricity will generate same time, a little bit temperature also generate. So that temperature can be maintained with the help of, so the FCC, that means fuel cell coolant will enter through this 3 hole and it will comes out through another 3 holes. Okay. So we have a cooling facility and also warm-up facility also available to avoid this kind of ice formation in the fuel cell. If ice form, then what will gradually only, maybe an entire air pass or oxygen flow is not totally 100% blocked. But if gradually ice is creating, what will happen? The generation, the electricity generation efficiency will degrade. Now here we are showing the exhaust system from the fuel cell stack. So fuel cell stack assembly attached with an exhaust pipe. It is not similar to our exhaust pipe in the IC engine. This exhaust pipe made with a plastic only, because the temperature of the exhaust gas is around 80 degrees centigrade. This is going to drain the water also, because water is due to the chemical reaction between inside the fuel cell, what reaction is happening? Oxygen and hydrogen merge together and they are developing water. So FC system produce water as a byproduct of electricity generation. Okay, some part of the water we are using to moisturize the air supply, because we are not supplying the dry air. We need little bit of moisture content, because the polymer electrolyte membrane in the fuel cell it will work 100% efficiently with the help of water only. If there is dry membrane, the percentage or the efficiency of the membrane will be around less than 40% when it becomes dry, or sometime it can be below that. So to improve or to maximize the efficiency of the polymer membrane in the fuel cell, we need water in the air system. So some part of the water generated by the electricity generation will utilize to moisturize the air which is supplying to the fuel cell. Okay, then the remaining water is discharged through the drain pipe. So the pipeline which we are showing here for not only for the exhaust gas which is coming out from the fuel cell, also for the water. So the water from the FC stack will be discharged through the exhaust pipe. The amount of water may vary according to the acceleration, deceleration of the vehicle. So it depends upon the vehicle operation condition. The amount of water generated will be vary. Okay, we can say from the module, from this fuel stack module, around 20 to 30 cc water per minute will generate. So from that, some part will go to the moisturizing purpose. The remaining will come out, but it is not continuously flowing to the road. There we have some system provided. Intentionally, the driver want to release the water. There is a button available in the vehicle. With the help of that button, we can release the water. Otherwise, whenever after turning off the power switch of the vehicle, or when you come finally when we stop the vehicle, the power switch will turn on. So vehicle will come out of the ready mode. At that time, the FC air compressor, we have an air compressor together with the powertrain, that air compressor will not turn off. It will still running to generate more compressed air. And that compressed air we are using to throw the entire water from the system, even from the fuel stack. Okay, so that's why we can reduce the icing. It will, by force, it will send the water particle through the exhaust pipe. And we have a shutdown purge mode. We call that operation is a shutdown purge mode. After power off, this mode will activate to discharge the water from the FC stack. Okay, that is coming through the drainage pipe only. Normally, when we shut down the vehicle, the shutdown purge mode will bring around 200 cc water through the exhaust pipe. So if in case anybody is standing behind the vehicle, there may be splashing of water towards him. Okay, so we have to be very careful while stopping the vehicle. If anybody is standing behind the vehicle, there may be a chance of splashing of water. Now let us see the transaxle of the FC system, a fuel cell vehicle. The transaxle is composed of many components. It is comprised with the FC water pump is there for the cooling purpose, and air compressor for supplying compressed air to the fuel stack, and AC compressor to generate heat and cooling. Is a EV transaxle. That will be the major part of the transaxle assembly. That EV transaxle having an electric motor generator. Why motor generator? Because it can act like EV. EV motor, we never say motor. It is a motor generator. So that motor having a capacity of around 113 kilowatt maximum output. Its torque is around 335 Newton meter in this vehicle. And there is forced circulation oil cooler, because this system running with the oil, the motor is immersed in the oil. That oil will continuously flow through the cooling system, and that will cool the entire transaxle. Okay. And we are using a planetary gear mechanism to reduce the motor speed. Every electric vehicle motor and motor speed reduction mechanism will be there. Here we are using a planetary gear mechanism, and also the differential is a preloaded differential we are using. Normally nowadays most of the vehicle using the preloaded differential system. And transaxle fluid, normally most of the manufacturer, even Hyundai, Kona, MG, all electric vehicle using the same WS world standard or automatic transmission fluid. The capacity of this transaxle is around 4.2 liters of fluid is there. And the period of, what is the interval of changing this fluid? Normally companies are saying this is lifetime you can use, no need to replace. But if you can change it in every 160,000 kilometer, that is around 3 to 4 years use, you have to replace the. Now, when we are coming to the hydrogen system, so far everything okay? Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. So here we are showing the hydrogen supply system. We have two tanks. One will be at the back side of the rear seat, and one is under the rear seat. So both are having different capacity. One will be 60 liter, another one 62 liter. See the connection. The red color area, this portion is high pressure area. That means both the tanks are keeping around the 70 megapascal pressure. Okay, and that gas pressure will reduce with the help of a regulator. So immediately after the cylinder, there will be a regulator. So that regulator function is to reduce the pressure from 70 megapascal to 1 to 1.5. So it will reduce to 1 megapascal, maximum 1.5 megapascal range. Then it is supplying to FC stack through an injector. So a set of injector will be there here we are showing 3 injectors. That injector function is to further reduce the pressure from 1 megapascal to 0.4 or 0.04 to 0.2 megapascal, or we can say 40 to 200 kilopascal. So this is the way we reduce the pressure, and finally the injector is continuously spraying and depends upon the instruction from the FC vehicle control ECU, fuel cell vehicle control ECU. But the injection is not continuous. It is according to the demand from the drive torque or the load requirement. See, here you can see the fuel hydrogen will circulate inside whenever the pressure and the quantity of hydrogen is reduced or the demand is increased. That time only injector will supply. Otherwise, it will continuously rotate inside, okay, through the FC stack, because the power demand is based on the drive torque and the other devices which is connected in the FC vehicle. So here you can see air is continuously supplying, and finally the output is going, the exhaust gas is going to the exhaust gas pipe. Here again the hydrogen system with the 2-cylinder. Here we are showing the filling and delivering procedure. Say we are not using the filling port for delivery. So each cylinder have 2 separate valves. So the blue color lines are showing the refueling, and the olive green or light green showing the fuel or hydrogen delivery. So each tank have filling valve and delivery valve. Here also we have filling valve and delivery valve. So the blue one is refueling valve, and the light green is supplying or deliver to the FC stack. From the tank, one manifold is for the fueling and another one manifold. Why we are using this manifold? Because both the tank are connected together. It is an integral part. There is no separation with the valve or solenoid, nothing. They are all, both are like, they are acting like a single tank, and the delivery side also, we supply side also, we have a manifold to connect both the tank. So when you are delivering hydrogen to the FC stack through the regulator, it will consume from both the tank. While you are filling time, also both the tank will simultaneously fill with the hydrogen. So this receptacle is a pipe with some mechanism is there, like to hold to avoid the leaking during the time of filling. That we can discuss in the pre-fueling time. Now, the regulator which is reducing the pressure and sending 1 megapascal to 1.5 megapascal pressure hydrogen to the FC stack. Here we can identify the high pressure line and low pressure line by colors. See, the tanks are connected directly with the filling system. A color code is provided for the high pressure pipe. Red color pipes are high pressure pipe, and the metal color pipes are metallic color, mean there is no cover or not colors are provided, just metallic color is medium pressure. Inside the stack we have a low pressure, that is less than that will be around 200 kilopascal only. Okay, now you can see the entire fuel system diagram. Here we have stack assembly. The stack assembly is holding the fuel cell stack plus hydrogen supply and also solenoids. Then we have a inverter with a converter assembly where we have a high voltage system You see the orange color lines are high voltage wires, which is coming from fuel stack 370, then boosted to 650 voltage, then supplying to the drive motor and coolant motor and also the air compressor. Here we have air supply system. Air supply system, the filtered air is converted into high pressure with the motor, and then we have an intercooler. That intercooler cooling the compressed air and supplying to the stack assembly. This is the hydrogen supply system. 2 tanks are there. Both the tanks are connected with the manifold. So the pressure is simultaneously delivering to fuel stack, and also filling time. Simultaneously, both the tank are filling at a time. Okay, and this will be the exhaust pipe. About the hydrogen tank. Hydrogen tank, see the construction of hydrogen tank. 3 type of materials are using: plastic inner line and also carbon fiber. That will be the core of the hydrogen tank. The main, all the engineering qualities are provided by this high carbon fiber reinforced ply, CFRP. And the outer part is made by glass fiber. So glass fiber, the main purpose is to protect the exterior. The entire pressures, the load from the external, all are withstood by the carbon fiber only. The inner plastic liner is mainly for avoiding the hydrogen leak. See the capacity of both the tanks showing here. The tank which is under the driver seat is around 60 liter. The tank provided in the back side of the driver seat is around 62.4 liter. Now we are coming to the safety side of the hydrogen fuel cell system. See, fuel cell system is like a high voltage battery electric vehicle also running with a higher voltage. So any voltage more than 60 is hazardous to the human being. So whenever we are handling these type of vehicle, we have to take a special care. So what are the steps to handle the hydrogen powered vehicle? Here, first of all, we need some, whenever you bring this vehicle for testing or any kind of research or even doing some kind of inspection to measure the voltage or to measure the pressure of the system, whatever you want to do, touch the high voltage area, we need to put the sticker on the vehicle. If you can provide the technicians or who are working on that vehicle, his number also much better. And both that instruction must be there on the vehicle that this vehicle is under repair. Please do not touch without permission. Okay, like that warning should be there. That will be the first step. Then we need a personal protection equipments like safety shoe, insulated glove. Insulated glove means the glove with the ISI mark can withstand up to 5,000 voltage. Gloves are required. Okay, then how to shut off the power supply first. So the vehicle, you know how to turn off the vehicle. Everybody know that, but should not keep the ignition key inside the vehicle. Keep the vehicle key after turn off the vehicle. Keep the key away from the vehicle, around 1.5 meter away from the vehicle. So the key will not communicate. Nowadays, everybody knows smart keys are there. That key will communicate with the vehicle. So that time we can avoid that communication. After that, take out the negative terminal of the 12 volt battery, because the entire vehicle is handling by the 12 volt battery only. So there is one more battery will be there, because which is not a part of our fuel system. That's why I didn't mention. That is part of the body electrical. So that battery will shut off all the electrical system in the vehicle. But still, we have high voltage in the high voltage side. That we are coming to that area. After shut off the voltage, we are going to remove the service plug. Okay, so remove the service plug to cut off the high voltage from the fuel cell stack and also from the high voltage battery. Then we need to inspect. I will show you one by one the steps here. This will be the high voltage service plug provided on the top of the fuel cell stack, and one more will be at the backside with our high voltage battery. Both the service plug must be removed properly. So to remove, we have a safety precautions. Please wear gloves, ISI marked gloves, and then follow these steps. Okay, I'll show you the steps. This will be the step how to remove the service plug. The service plug, first step, you have to pull and then make 90-degree, then take it out. While inserting time also, we need the same, just opposite to that procedure. Insert it and then bend 90-degree, then lock the system. Okay, there will be a clicking sound while you are pressing it back. Okay, before that, the service plug design is like this. How it is connected with the high voltage system, you can see here. This will be the fuel stack. Fuel stack is like a series of cells connected together. That fuel cell stack providing to 370 voltage continuously. If there is oxygen and hydrogen inside, it will generate. That's why we want to cut it. We want to touch the booster converter or any electrical components. We need to make sure that no voltage is provided by the FC stack and also high voltage battery. So normally when you turn off, these two relays will turn off the power supply, but we need 100% surety. That's why we are removing this service plug grip. So there is no power supply to the outside circuit. What will be the next immediately after the fuel cell stack? Our boost converter. So boost converter will be switched off immediately. So no power supply. But still cannot believe because there is one more step available that we need to make sure that system voltage is zero. So we have a inverter converter assembly in the engine room. Just open the hood and there we can find out two inspection points are provided, one for negative and one for positive. So we have to use voltmeter can measure up to 750 voltage because this boost converter using high voltage capacitor for boosting purpose. So that inverter and converter and also boost converter using capacitor. These capacitors can store some amount of electricity. So to make sure we need to measure. So before measuring, you have to give 10-minute time to self-discharge this capacitor. So after 10 minutes only, both the service plug has to remove first. Then we will come to measuring and confirming zero voltage. Once it is showing zero voltage on the multimeter, now you are free to do anything. If you want to do any inspection, because nowadays fuel cell vehicle in India, we are just using only for the studying purpose and doing some testing, some validation process, everything going on in the university level. So that's why I'm giving this instruction because we have to be very careful about the high voltage system. Now, how to do the refueling? Refueling also, there is a button available to open the fuel tank lid, but it is not same like our conventional vehicles like IC engine vehicles, petrol tank. While you are pressing, automatically it will open. But here you have to wait around, you have to turn on the, press the button, turn off the switch. First of all, it comes out from the ready mode, mean turn off the ignition and remove the key, press the button. Within 5 minutes, you have to come and, because if you are doing that step after 5 minutes, again, we have to do the same process. That is for safety purpose. So we have 5 minute time to come and press the fuel tank lid. When you open the fuel tank lid, what is inside? Still one more cap is provided there. That cap is for safety of the receptacle inside the, because which is connecting directly to the fuel hydrogen tank. Okay, so this must be very clean. No dust and water. You should not allow any dust or water. If that cover is open, don't think about washing of vehicle. Anything. Okay, so open it and fill the fuel. After that, we have to close the lid, then only the vehicle will move. If you forget to close the lid, the vehicle will not move. The ready mode will not come. So first of all, we have to fill the hydrogen and then close the lid, then only you can turn on the vehicle. In case while filling hydrogen, if you come and touch the ready mode or by using the key to turn on the vehicle, that time what will happen? Ready on will not be function. The vehicle switch on function will not happen. That is for safety purpose. Okay, and the system will record one error code in the system that service people will find out to see what will even manufacturer can see that data later on. Okay, that's all about the fuel filling. Now we are coming to the last section. These vehicles, fuel cell stack, just converting the hydrogen and oxygen into electricity. So we can use this vehicle like a power source, like a generator. There is a plug available at the back side of the open the trunk. You will see, so the steps are showing here. Number one, we will remove the cover and insert this external power source, power supply unit is there. Nothing, because we are using DC source. So we need an inverter. So that with that inverter, you can operate any domestic appliance. The process is very simple. Open and connect the external power supply unit and then turn on the power. Then one more step is there. There is a DC out button available in the vehicle. While you are pressing that, you will get power supply. Even your house can be, if there is an inverter connection with your house, then you can connect that plug with the vehicle. So you can use this vehicle like a generator. Okay. So with that, we are winding up. So let us see the subject again, fuel cell system. In that we discuss about the fuel cell stack and the cell construction, everything. What was the next? Fuel cell transaxle, then hydrogen system diagram, high voltage system for safety, and also service plug for the safety, voltage inspection procedure for the safety, and finally refueling procedure of a hydrogen fuel cell vehicle. And a fuel cell vehicle can use like a power source for our domestic purpose. With that, we are coming up with the end of the presentation. Now, question and answer section. Do you have anything to specifically from the presentation, anything to discuss?
Professor, I have one question.
Tell me.
Actually, major issue is that of safety one with the use of hydrogen vehicle, right?
Yes, exactly. Now, these vehicle, the one we shown, I was showing throughout our presentation, is the first generation, because that time 79 megapascal capacity was the tank capacity, the pressure capacity. Now they have reduced. Toyota and other manufacturers also reduced. You can see in India now a lot of heavy vehicle manufacturers are moving with the fuel cell vehicle, and also hydrogen powered IC engine also available nowadays. So the tank capacity now, the tank pressure is reduced because of this safety issue. Because if hydrogen is leaking, it is like a highly explosive gas. So you are correct. We have continuous improvement is happening, and 4 sensors are provided inside the vehicle to observe the hydrogen leak.
Professor, my other question is basically, is it only the electrolysis process which will generate the hydrogen, or some kind of other processes are there, like renewable energy sources or something like that, or biomass, from where we can get the hydrogen? Because electrolysis process is a very costly process, right? And the cost of the vehicle will also be affected if we use electrolysis process. And second, another problem is that generation of water, and we need some kind of water also parallelly, right?
Oh, yes, your question is very valid question. You are absolutely correct. See, hydrogen production, hydrogen is abundant element in our globe. Around 90% hydrogen molecules are there. But see, there are in Western countries what they are practicing. See, hydrogen can even from garbage you can generate hydrogen. That is the advantage. From garbage, I mean, even the effluent like wastewater. Wastewater, the best process to purify that water, electrolysis. So we will extract the water from that, then the rest can be processed separately. That is one way. Exactly, I agree with your point that voltage, I mean, again, the electricity consumption will be there. But, now the power sector is facing a large problem, like where to say the usage of electric power is not always stable. There sometimes we are generating abnormal electricity with the help of a solar system and a windmill, but we don't have any consumer. At that time, where to store? That's why V2G system, like a vehicle to grid system, some of the vehicle we can use to store that electricity during the peak generation, and then it is returned back. That time, they are planning to generate that excess electricity will convert into hydrogen. You got it?
I got it, sir. Got it.
Yeah, in some area like offshore in the sea, lot of windmills are nowadays they are installing, but bringing that electricity into our land area very difficult because longer cable required and transmission loss will be there. But those power plants, those windmills can convert that electricity with the help of because seawater also available. So easy to convert that seawater into hydrogen. So like that approaches are going on, but maybe some other solution will be there.
Thank you very much, Professor. It was a nice presentation.
Thank you, sir. Thank you very much.
Hello.
Yes, sir.
Yeah, myself Prem Shankar Yadav. Sir, actually, currently I am working on biofuel and IC engine. So in IC engine, we have seen that maximum efficiency is 37-38%. What is the efficiency of fuel cell vehicle?
Fuel cell vehicles are around, as per my knowledge, it is giving around 70 to 80% efficiency. I mean, compare with the IC engine. IC engines are also improved much because Toyota IC engine for hybrid vehicle giving around 40% thermal efficiency, I mean output efficiency. Yeah. The fuel cells are comparatively better. So exactly what the efficiency, what will be the actual efficiency at the current fuel cell, because the fuel cell technology is continuously modifying. So what is available in the right now in the market, which I am not familiar, I will get it and give you that answer.
Okay, sir. Thanks.
Okay, thank you, sir.
Good evening, Professor.
Good evening.
Yeah, my name is Dr. M. Muruganandam from Muhammad Sadak Engineering College in Ramanathapuram. Actually, yes. Hybrid vehicle. So, is there any gas separator, sir? Gas separator from exhaust manifold. From exhaust manifold, we got so many different type of gases like carbon dioxide, NOx, and other things. Is there any gas separator available
for hybrid vehicle or fuel cell type of hybrid vehicle?
Fuel cell hybrid vehicle, sir.
So fuel cell hybrid vehicle, the exhaust is just the air only, air without oxygen. That will be the exhaust. But due to the electric generation, the temperature will be little bit high. That will be around 80 degrees centigrade. And there is no separation, just water. Water will accumulate in the tank. And during the time of shutdown, that shutdown purge process is there. That time we will throw the entire water back outside the exhaust system. We are not, in my knowledge, we are not separating any gas because the exhaust is pure water and air only.
Okay. Okay, one more question, sir.
Yes.
In conventional engines, sir, actually, the exhaust manifold, we received a lot of gases, no other carbon dioxide, carbon monoxide, NOx.
Yes.
So
yes.
that we are going to convert it into the useful product like methanol, like we are going to convert it. Is possible, sir?
See, right now, what is the technology available for gasoline engine or CNG engine? There is a catalytic converter. So catalytic converter converting that exhaust gas into our normal atmospheric gas, like a greenhouse friendly gases. So there will be carbon monoxide, nitrous oxide, and hydrocarbons. So these are the three poisonous gas coming out from the engine exhaust, which we will convert into CO2, carbon dioxide, nitrogen, and water molecules, oxygen. That's all. So what type of conversion you are planning?
Okay.
This catalytic converter is already available. Other than catalytic converter, one more filter is introduced recently because of the Euro 7 norms. They are planning to introduce particulate filter together with the catalytic converter. So if you gasoline also having little bit of particulate material, in diesel we have more particulate material. So that will be one more additional system. That's why people are moving to e-mobility and hybrid version, because the emission in hybrid and EV, you know that EV zero emission, hybrid vehicles are almost compatible with the Euro 7.
Okay, sir. And one more question, sir. Most of the e-vehicles are in India, sir. Actually, most of the vehicles are burning.
That and all gossips only. See,
So what is the
every
reason, sir? No, I want to know the technical problem, sir.
See, nowadays, n number of manufacturers, lot of manufacturers in two-wheeler section, in the two-wheeler sector, lot of manufacturers are there. Kit assembling.
Yes, sir.
I mean, they don't have proper R&D system or proper testing facilities. So what is happening? The quality of the battery, quality of the controllers, especially BMS, battery management system. You know that battery management system, without battery management system, a proper management system, you cannot use lithium-ion battery. So
Yes, sir,
they are very sensitive because the voltage level cannot increase more than 4.2 and the cutoff voltage is 2.5. So if you are bringing back to 2.5, that the life of the battery will be affected. If it is going more than 4.2, there is a chance of thermal runaway, or even the temperature of the battery need to maintain properly. So all this function done by the BMS, an efficient BMS. So some people are going for cheaper. Hello. Cheaper versions of batteries or cheaper version of BMS may damage the vehicle, and the burning stories are. I don't believe that even when we introduce the early stages gasoline vehicles, there were same issues. People were afraid to touch the gasoline vehicle because chance of fire. Now we are handling gasoline like anything. Even CNG vehicle is dangerous, but we have technology, we have safety precautions systems. So, but the only one thing that we need to go with the quality products.
Okay. Thank you, sir. Thank you.
Hello.
Yes.
Hello, sir. Good evening, sir.
Good evening.
My name is Anil Kumar. Yes, sir. I am a solar professional. I have one doubt about the fuel cell system.
Yeah, tell me. Hello. Hello. Hello.
Yes.
This is Prathamesh. I have a question.
Yeah, tell me.
Sir, Toyota and JCB are developing engines that can be run on hydrogen fuel. So what are your views regarding it?
Pardon your question. One more. Toyota
and JCB are developing engines that will run on hydrogen fuel.
Yeah. IC engines also parallelly coming, not only in Toyota. Here in Tata already introduced that engine prototype model is available with a hydrogen engine.
Okay.
Yeah, so a little bit modification is required because you know the temperature of the combustion temperature. So components like a valve, injectors are specialized. The total system need to be modified. You cannot directly. Maybe in the future retrofit kits may available for hydrogen combustion, but I'm not sure whether it will happen soon. A lot of work, research works are happening. So soon those type of vehicle will be available. Again, one issue is there, like moving components, like tear and wear will be there. Reliability issues will be there.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Thank you.
Sir, one more question. Sir, myself, Prem Shankar Yadav. And sir, your presentation was excellent. And just I want to know that what is the major challenges for fuel cell vehicles?
See, fuel cell, same like infrastructure must be improved. See, we don't have filling stations. Now, see, there is vehicle available, but how we can fill hydrogen? So we need to develop the infrastructure for hydrogen filling. That will be one major challenge. And also, same time, the manpower, who can repair the vehicle. So we need to parallelly develop the technicians. So many challenges are there. From the vehicle side, now see these vehicle almost 10 year Toyota was testing all over the world, all kind of terrain, all kind of weather. They have tested and collision test. But still, safety issues are there. In every vehicle, safety issues are there. But that and all marginal. But the other issues like infrastructure facility, like how to fill the bringing hydrogen, producing hydrogen, and supplying hydrogen. And pan India, we need to develop filling station and supplying hydrogen. So these are the challenges.
Okay, very good, sir. Thank you, sir.
Hello.
Yes.
Sir, in case of cost wise, with respect to electric vehicle, so if I want to compare with a fuel cell vehicle and electric vehicle, so who is the highest cost layer, and what is regarding efficiency also?
See, now at present, the vehicle which is available in India, which is very costly, that is more than crores, because of not only because of the fuel cell system technology. See, these vehicles nowadays, they are not producing in an automated production plant. They are assembling like a manual assembly only happening because of they want to assure 100% safety. So once it is coming into the normal production line and once the systems are, tax problem issues are, when we are importing, tax issues will be there. Now, locally, this technology available. In India, we have our own fuel cell technology. When we are developing those technologies, sure, the cost will be maybe less than, or because the size of the battery is very less. Compared with the EV, we have around the size of the battery, we can say less than 20% size of the EV battery. So that's why battery cost will be less. Only the cost is hydrogen tank construction, and also the fuel cell stack will contribute major part of the cost. So cost in coming future, when we have a mass production, of course it will come down, and also depends upon the local technology.
Yeah, thanks.
Good evening.
Hello. Good evening. Yes.
Yeah. Sir,
myself, Vinula.
Yeah, tell me.
Sir, what is the major loss that occur in hybrid fuel cell vehicles, which affects the efficiency?
Major losses, you mean which area we have efficiency issues?
Yeah, yes, sir. Yes, sir.
See,
that affects
right
efficiency,
now,
overall efficiency.
Overall efficiency compared with, see, this is 100% electric driven vehicle only. The drive side is 100% electric vehicle only. Only the power generation, see, EV, we are using a bigger battery. In this vehicle, we don't have a battery. We are using. So whatever efficiency is.
With the hydrogen tank.
Motor side, same 80% or more than 80% efficiency we can get, because motors are much efficient than the. That is also again depends upon the technology what we are using.
in case of fuel cell, as you have a knowledge that which laws that affects by some
Still-
as we see electric vehicles that through heat we can see some major issues like burning. That all.
Yes. Yeah, issues are there, but say currently vehicle around nearly 1 million vehicles are all over the world, I think, because Toyota the number of vehicle available in fuel cell vehicle available in US market, and in Asian area in Middle East, I think Saudi Arabia is second. And also some of the Middle East countries are now increasing their fuel cell vehicle. Japan, outside Japan, Europe, US are number one. They are using this vehicle. There is very less problems only reported. So far, no any hazardous, no any major issues are not reported. See, if you are thinking about the battery issue, we are using NIMH, nickel metal hydride battery, which is more safer than lithium ion battery.
Sir, what is that battery type of?
Pardon?
What is the battery type that you say that?
Battery
Type
pack.
of the battery.
NIMH means nickel metal hydride battery. Yeah.
Okay, thank you. Thank you.
Sir. Good evening, sir.
Yes.
Hello.
Good evening. Good evening.
Sir, recently we have seen that our Road and Transport Minister Nitin Gadkari also promoting fuel cell car like Mirai, Toyota Mirai.
Yes.
But still we don't have any fuel stations and any hydrogen fuel reservoirs. So what steps to be taken, or by when can we see the fuel cell driven batteries, driven cars in the market?
So according to my knowledge, Reliance Group already started. Many of the manufacturers in India started that process for producing hydrogen soon. And also the R&D level, university level process is going on, and prototype vehicles are ready. So soon we will switch into, because the major issue for the EV, that lithium availability, mining of lithium. So these are all, we are not rich in lithium, India. So for us, hydrogen fuel cell vehicle will be an added advantage, because we don't need to depend more on lithium side, because the battery capacity will be very small. So we can that will be one of the advantage for us. Another thing that hydrogen production is not that much complicated, and the solar panels, daytime they are having a surplus production. So those solar panels need a huge battery system to store the solar energy for the purpose of night usage. So if we can rely on fuel cell system, that fuel cell system can convert that hydrogen production can convert those solar power generated electricity into hydrogen. And that we can supply to the automotive sector and also some other power generation purpose. Understand? So these are the possibilities of hydrogen fuel cell in India.
Hello.
Yes.
Sir, recently we have participated in competition. ISA only conducted that in Coimbatore only.
Yes.
Noida, Greater Noida only, sir. So on that day, our bike will having a battery 72 or 30 Ah, sir. So it was riding around 13 kilometers, sir. But after that, it was stopped fully, sir. So on that time, I checked that battery voltage, it will showing 0, sir, fully. So when we remove that compartment also, on that time, after that 15 to 20 minutes, it's showing 72 volt only. But why that fully down that battery, sir? For what reason? We didn't get that.
See, normally your mobile phone also always it will show 0 voltage and it will shut off. But internally, the battery management system is doing that function. They never switch off the battery into 0 voltage level because there is a cutoff voltage and a safe voltage level. So once it is reached to the certain level, like 2.5 is the cutoff voltage for lithium ion, and 2.7 they will turn off the system. Okay, so it is logic. I mean, only for the output level side, they are showing that voltage will be 0, but internally the BMS having a cutoff switch. Some of the BMS using internal cutoff switch, some of the BMS will send a signal to the other, like a relay system will be there, or some thyristor or any power electronic devices will be there. Those system will turn off and keep the battery in a safe condition. So I'm sure that if the battery still have around 30 to 40% voltage, capacity will be there. But as per the BM, it will show you 0 voltage, like your mobile phone.
Okay.
Good evening, sir.
Good evening.
What will be the life of your fuel cell?
Life of the fuel cell, right now I don't have any idea because I'm also looking for this in how long we can use. According to the manufacturer, what they are saying, that fuel cell must be kept in clean condition because the air which we are supplying, that will be the major dangerous part because there may be contaminated air, possible that dust or some accumulation can happen through the air. That's why we are using a proper filtering system when we are supplying air to the fuel stack. So this will be the enemy of, because you know the structure of the in our presentation I have shown already, the size is 1.3 mm and very tightly packed components. So it can blocked by the external particles like dust, some other foreign materials. That will be the. But we have chance to clean. We can dismantle and clean. That process also there. But right now nobody is doing. So life, how long? According to them, lifelong you can use.
Okay, great. Thank you.
Okay.
Good evening, sir.
Good evening.
So my question is, what is the heat capacity?
You mean the heat developed by the FC?
Yes, sir.
It won't go more.
Hello. Hi, good evening. I hope you all liked the session and enjoyed it a lot, and you have taken so much learning from it. So I just want to tell you about that ISI India provides various other courses for your skill development, and there are like courses for pay after placement also, that in which you have to pay after we provide 100% placement, and after that you have to pay when you are placed. So I'll just like to share you a video of our courses so that you can have a good idea. So
your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thank you everyone for watching the video. So if you guys want to enroll in any of the courses, you can send us the inquiry. The link is available in the chat box. So if you guys are interested in any of the courses, please fill up the form. And kindly, the students or the learner, those who are only interested in enrolling the course, they can fill up the form only. So I will be sharing the QR code as well. You can scan that and you can give us the inquiry.